Did you know there is a life cycle with a wind farm? Stay with me and we'll look at that. You and I have an insatiable appetite for electricity. Come with me and we'll look at the issues relative to wind farms and the communities that they serve. This is the Windfarm Guy. Hi, this is Dennis Stout and thank you for joining me for this episode of the Windfarm Guy. This episode is the second part in a series on wind farm basics. Today we're looking at the project life cycle. There are roughly 6 steps in the wind farm project life cycle. Each of these can be broken down even more, but for this video, let's just keep it at 6 general steps. Keep in mind that wind developers may approach these in different ways, but these functions are still happening. First, there's the feasibility assessment. Wind farm developers first try to find the right location for a proposed wind farm. In a nutshell, a successful wind farm will be the confluence of good wind, available capacity on a nearby transmission line, willing landowners, favorable permitting, and sufficient electricity prices. But that is just the beginning. When it looks like these factors might be coming together, then the team will dive deeper to determine the feasibility of the project. They'll look at existing wind data, the area of available land and its ownership, the ground conditions and current land use, and the county setback distances. They'll do a desktop environmental assessment, consider existing and future grid infrastructure, learn about community acceptance and their future plans, take a hard look at construction access to the area via public roads, see what existing or developing generators are in the area, and finally evaluate the electricity market. Second is development, which begins with land acquisition, acquiring the land for all of the infrastructure. And during this time, the wind analysis folks are using wind data to figure out the best turbines for the site and where to place them. Preliminary engineering is done to design the foundations, roads, collection systems, delivery routes, and other civil engineering things. The developer secures support from federal, state, and local governments and other taxing entities. They study the existing and future transmission situation and get the necessary approvals. They study and gather information on everything they can: roads, transmission lines, creeks, waterways, and wetlands, topography and ground conditions, pipelines, and more. More in-depth environmental studies are done that seriously evaluate wildlife and plant life, making sure there are no threatened or endangered species that would be impacted. Communication, aviation, sound, shadows, and archaeology as well, all with the intent of getting the necessary permitting from the county. Third, pre-construction. As the name implies, this is getting ready for construction. Contractors are hired, final engineering is done, components and equipment are procured, and financing is secured. Management plans, transportation plans, and compliant plans are completed. All the while, attorneys are going over every document to make sure all details are covered. Fourth, construction, otherwise known as installation. Foundations are dug, built, and poured. Roads are built or upgraded. Crane use areas are prepared. Turbines and other components delivered. Substations and other electrical infrastructure installed. Facilities for construction, operations, and maintenance are constructed. The Gen-tie transmission line is erected and necessary upgrades to the existing grid are made. In addition, the telecom, security, safety, suppliers, waste disposal, and other accommodations are put into place. Then, when all seems good, all equipment goes through a pre-commissioning process, which is basically test and adjust till ready to go. Then the main power transformers are energized, as are the circuits, and finished components are then commissioned, and the power is on. Fifth, operations. The project is fully operational and fully staffed. Functions are continually monitored and managed to ensure reliability and efficiency. These teams maintain the equipment and assure ongoing compliance with permissions, permits, and landowners. Environment, safety, security, and community concerns are also handled. The Supervisory Control and Data Acquisition System, or SCADA, helps monitor and control production and performance, and any faults lead to maintenance. There are also preventative maintenance opportunities that happen regularly. Sixth and finally is decommissioning. At the end of the life cycle of the project is its decommissioning. At this point is the dismantling, removal, and disposal of all above ground improvements, and the ground is restored to the prior use. And I'd like to take this opportunity to say that with improvements made in recent years, modern utility scale wind turbines are about 99% recyclable, including the blades. If you like what I've said today, be sure and click like and subscribe below. If you have thoughts or want me to address a particular topic relative to wind farms, please also leave me a comment. One final note is the possibility of a new lease on life for the project. It is called repowering. After the decommissioning of the old components, some projects are refitted with new, much more productive equipment and power is restored. Actually, more power is restored, much more power. This is called repowering, and the life cycle is restarted. Repowered wind projects are a boon for the landowner, the taxing entities, and of course the wind company as well. It's a win-win all around. This is Dennis Stout, and I'm the Windfarm Guy. Thank you for watching. Working together, we can make good energy decisions and save our planet. I am the Windfarm Guy.